Okay, lesson 67 is more area. The difference today is it's area involving functions of y. Okay, we have specifically focused with when we're finding area between two curves. For instance, in this first picture, f of x and g of x. How do we find the area between these two curves?
You would take the top minus the bottom on that integral.
Okay, it's the upper curve minus the lower curve, and we're doing the integral, yes? So if we were looking at this one, it'd be the integral of, what is our upper? F of x. So it'd be f of x minus g of x, and officially times dx, right? And as Ross said, that is upper minus lower. That's how we are taught there. And when we do these, we are doing these in terms of x. The ones we're looking at today are going to look more like this second picture. Okay? And as you look at these two pictures, if we're trying to find the area between the curves, okay, area between the curves up here was there, area between the curves here is that, can we really think upper minus lower? And that's the problem, we can't. Okay?
Right minus left.
Exactly. It is going to be right minus left. Now the thing is, when we're doing upper minus lower, our equations need to be in terms of x, and we're working in terms of x. When we do right minus left, our equations are going to need to be in terms of y instead. So we're going to work with y's. So, well, we'll get to today. And I guess what I will say, the idea here is when we do the upper minus lower, okay, what we're doing is we're doing these, it's kind of like, you know, remember how we start off doing rectangles, yes? The integral is just an infinite number of rectangles added up together. When we're doing the upper minus lower, we're doing the rectangles that go from the upper curve to the lower curve. So they are vertical rectangles, and those rectangles represent dx, okay? Whereas when we're doing right minus left here, our rectangles are going to be sideways rectangles. And those rectangles represent dy because they are, you know, there's infinite little rectangles there that we're going to sum up officially. Now, you'll notice if we're doing right minus left on this one, then that's going to be doing the integral of, which one's our right one? F of y. F of y minus g of y times dy. And as it was pointed out, instead of upper minus lower, it is right minus left. Okay.
Seems pretty straightforward.
It is. I mean, it's the hardest part is, here's the deal, are the equations always in terms of y we're given them? More often than not, we're given equations in terms of where it's y equivalents in terms of x. We have to do a little upfront solving, but it's still doable. Okay. Oh, this probably should have been up with the other one, but it ended up down here on this part. Other side comment, A and B values. So we're talking about A and B values. Those are the numbers we are integrating between, right? So we also have to think of A and B values based on the y-axis instead of the x-axis. Pretend you're looking at the picture sideways. So normally our A and B values are x values. Now they're going to be y values, which they should be y values if you're working in terms of y. Okay, shall we try the example one? Find the area of the region completely enclosed by the y-axis and the graph of x equals 1 minus y squared. It is actually in terms of y. But here's the deal. We also have to graph this. Because I have to know what's right, what's left. What's this graph look like?
So
I'm going to have to know my a and b values. So even though it's nicely presented that we can plug it into our integral,
we have to solve it for y so we can graph.
we have to be able to graph this. Somehow or another, you have to be able to know what this graph looks like, which I'm probably going to say, yes, let's solve it for y to graph it. However, if it was a single y equals x squared, what would it be? Y equals x squared is a parabola that either goes up or down. X equals y squared is a
Sideways parabola.
parabola that opens left or right. A normal sideways parabola is going to open right.
Left is left.
This is a negative y squared, so it's actually going to open left. The positive 1, normally a positive 1 moves us up,
But it was right one.
but this positive 1 is going to move us right 1.
That makes sense.
Now, if you're saying, what? Then go back to the let's solve for y. I know Ross followed that. I have no idea if anyone else followed that. So, I mean, it should at least somewhat make sense. Now, here's the question. Could you process through that on your own? Maybe, maybe not.
Maybe not the first time, but now I think I'm good.
Right. So, if we solve this for y real quick, I'm going to add y squared over to the positive side. I'm going to subtract x and add 1. Does that make sense what I just did? Sorry. I added y squared to the left. At the same time, I subtracted x to the right. And then we would have to take the square root of this. And so when you graph this, what's the catch here? Y equals plus or minus the square root of negative x plus 1. And I'm only doing this in case you want to put it in your calculator, right? Because could you graph these two pieces in your calculator and hopefully get a sideways parabola that matches what I was talking about? Hopefully. Okay, let me set up a graph. X-axis, y-axis. And, I mean, keep in mind, this kind of has to be somewhat particular, doesn't it? To know what this truly looks like. Did you try graphing on the calculator? Did it work out? To be kind of what we talked about, that sideways parabola there? Yep. Okay. So, whether you can process through it as a parabola, whether you need the calculator, it shows two halves. It actually looked like it was connected fairly well in that piece. Yeah, it actually connects fairly well. Okay. So, pay attention. It looks like a vertex at 1 on the x-axis, so 1, 0. Pay attention, where does it go through on the y-axis?
This is 1 and negative 1.
It's 1 and negative 1 because, think about it, this parabola is just a y squared. There's just a coefficient of 1. So it goes back to that same thing. Once you know the vertex, from the vertex, normally we say over 1 up 1, over 2 up 4. This would be, you know what I mean. Just turn it sideways. It would be up and down 1, left or right 1. Like, that's hard to say. You guys know. So it is going to go through 1 on the y and negative 1 on the y. And you get that picture from me. I think a lot of you looked at it on your calculator, so that's good. What area am I finding here?
The area of the little hill that's on the right side of the x-axis or y-axis, right?
Yeah, the area on the right side, because it's enclosed by y-axis in that graph. So y-axis in that graph is right there. What intersection points do we need to pay attention? Well, and I guess in case this was your y equals square root of negative x plus 1, right? That was y equals negative square root of negative x plus 1. We got this point right here of being at 1, 0, yes? What are these points on the y-axis? Yeah, they're going to represent A and B, aren't they? They are the ordered pairs, 0, 1, and 0, negative 1. So what are my A and B values going to be? Negative 1 and 1, because remember, they are the y values. So normally our A and B values come from where our graph crosses the x-axis. This is going to be where our graph crosses the y-axis. Okay, we ready? There you go, you get an integral. It's area under the curve, area between the curves. Okay, so what am I doing here?
Integrating on the integral negative 1 to 1, the 1 minus y squared y, right?
Yes. Now technically, if we're doing right minus left, what's my right curve? My right curve is the bottom of the parabola, which is 1 minus y squared, correct? That is the right curve. What's the left curve? Because that's all Ross integrated there, was 1 minus y squared. What is that right curve, or left curve?
The y-axis, right?
The y-axis. And what's the equation of the y-axis?
X equals 0.
X equals 0. So when we do this, we're doing the 1 minus y squared minus 0. Kind of like if you go back a bit, when I first taught you area under the curve, the bottom was always the x-axis, right? So I didn't even teach the subtraction thing. It was just you integrate the curve. Kind of the same thing here. But I want you to realize we are doing right minus left. It's just that our left here is 0. So officially, I'm going to put this as the 1 minus y squared, and I am going to say minus 0, just for the purpose of having it there, dy. Do you remember that negative 1 and 1 are y values? Don't forget that. Okay. What's the integral of 1? Y. Minus the integral of y squared, 1/3 y to the third. The integral of 0, nothing, doesn't matter. And this is going to be evaluated from negative 1 to 1. I know not everyone's taken that last test yet, but there have been some basic mistakes about integrating. About forgetting to integrate and just plugging 1 and negative 1 into the original problem. About integrating, but then still plugging 1 and negative 1 into the last problem or the original problem. I don't know. I've seen some weird things done, so I don't know. Make sure we know how to integrate. So, and the thing is, I honestly think I've seen it on the last 2 tests, honestly. I don't even think it's just been the last test. I think it's just been weird stuff that we're having issues with. So, okay, first thing I'm doing is I'm plugging in 1. So 1 minus 1/3. And then it's going to be minus. Now I'm plugging in negative 1. Negative 1 minus negative 1 to the third It's going to be negative 1. So that's actually going to become plus 1/3 the way I have it written. I don't know. Meet me at the end if you're doing your own little thing here, right? Did you guys meet me with 4/3? I had 1 minus 1/3 when I plugged in 1, which became 2/3. There's something else I saw weird things happening with. Do you remember it is subtracting upper limit minus lower limit? Remember you plug in the upper limit first, then the lower limit. As I said, I've seen weird stuff happening lately in the last couple of tests. And then when I plug in negative 1, it was negative 1 minus negative 1/3, so plus third. Negative 1 plus 1/3 is negative 2/3. 2/3 minus negative 2/3 is 4/3. Questions? Okay, example 2. Find the area completely bounded by the graphs of x equals 3 minus y squared, excuse me, and y equals x minus 1. I was really trying to hold that off until I read the problem, but it wasn't happening. Well, I'm going to say we need a picture. Because it's hard to know what's right, what's left, what boundaries we're using if we don't know what it looks like, right? And hopefully I'm making a valid point here. Okay. Let's graph them. Or which one are you starting with?
The parabola.
Oh, you started with the hard one, the parabola. Okay. If we look at the parabola, x equals 3 minus y squared. Now, can you solve that so you can graph it on the calculator? Yes, you can. Right now it's x equals, so it's ready to take 3 minus y squared and put it into our interval. That's what it's ready for. Okay? But x equals y squared is a sideways parabola. Negative y squared says it opens left. Positive 3 says that vertex moves right 3. Or, let's see, if I add y squared over and subtract x, y equals plus or minus the square root of 3 minus x, if you want to plug that into your calculator, right? So, now, be careful here. I have a vertex at 3. That would be 3, 0. You need to pay attention to where your other points are because it's going to matter. So I'm going to try and draw a very precise drawing for my vertex. Where do a set of points go? The first set of points are 1, 1, right? We normally say over 1, up 1. So I'm going to go up 1, left 1 to put a point, and I'm going to go down 1, left 1 to put a point. Does that make sense? Those are 1, 1 from the vertex. I'm also going to go ahead and put my 2, 4 set from the vertex. Granted, I know a little bit about what's happening with this problem, but so if I go 2, 4 from the vertex, I'm going to go up 2, and when I go left 4, I end up at negative 1, I believe. And then when I go down 2, I'm going to end up at negative 2, but then I'm going to end up over here at negative 1. You got your parabola points in there? Don't like, redo. Getting that parabola to hit those points was a little awkward. I think that's just how my graph is set up. Now, nice part about y equals x minus 1, it's ready to graph. It's not ready to integrate, but it's ready to graph. So y equals x minus 1 is a line that has a y-intercept of -1 and a slope of 1, which means my slope is going to go up 1 over 1, up 1 over 1. It can also go down 1, left 1. You have some good intersection points happening. Now, I don't know. This is a weird angle. I don't know that I can connect these. I'm going to do it in portions because, well, we'll go with it. It's a little rough, but okay. Those of you that graphed on the calculator, your picture looks good, right? Or maybe, I don't know, maybe no one graphed on the calculator this time. But where am I trying to find the area? Kind of similar to the last one, except this time it's the area bounded by these graphs. So we've got those two pieces right there. Now for our parabola, it's x equals 3 minus y squared. So we're going to use 3 minus y squared when we're ready. What about for the line? Yeah, add the 1 over, and x is equal to y plus 1 when you solve it for x and make it in terms of y. X equals y plus 1, you're going to use the y plus 1. So those are the two pieces you're putting in to integrate. What about boundary points, my A and B points? You're looking for where these two curves intersect. So the top point is at, what is that word pair? 2, 1. My bottom point is at the ordered pair -1, -2. Do you see why I was so specific about how I graphed mine? I didn't just draw a line and a parabola because I have to know these points, right? Now, what values am I using from there? The y values, so 1 and -2, is that what you guys said? Okay. Integral from -2 to 1. And remember, those are y values. Right to left, or right minus left. What's my right curve? The parabola. So I'm going to say 3 minus y squared minus my left curve. What's my left curve? Y plus 1 times dy. And again, remember these a and b values are y values. You don't have to write the y equals in there, but sometimes it's just helpful, I think. I would recommend before you integrate this, can you do a little cleanup? It's not much, but there's a little. You can take it from 4 terms to 3 terms. So I would say before I integrate, I'm going to say the integral from -2 to 1. Whole number 3 minus 1 is going to be 2. There's still a minus y squared, and then it's going to be minus y times dy. And that's what I would integrate. You ready to integrate? Integral of 2 is 2y minus integral of y squared one-third y cubed minus the integral of y 1/2 y squared evaluated from -2 to 1. I think I'm going to bring mine up over here. If I was on paper, I have more room on paper, but I'm out of room on my screen. Not quite, but I don't have enough. Okay, so first thing I'm going to do is I'm going to plug in 1, 2, minus 1/3, minus 1/2 is what I get when I plug in 1. Then I'm going to subtract. And now I'm going to plug in -2. -4. -2 1/3 is -8. -1/3, so plus 8/3. That's going to be 4 divided by -2 minus 2. You taking your quiz?
Yes. I got the study hall and then people were talking about, oh yeah, I'm looking at the quiz. And oh yeah, I'm supposed to do that. So I was like, oh, that's today.
So, there you go.
Thank you.
You're welcome. Okay, are you guys doing the math? If I'm doing this without a calculator, I'm going to probably think common denominators. I can do a common denominator of 6. 12/6 minus 2/6 minus 3/6 on the first part. So that first part is 7/6 in my brain. The next part, well, do I want to do, eventually I'm going to have to end up doing 6, aren't I? I don't know. A couple different ways you can do this, I guess. Because I'll be honest, my brain says, oh, -4 and -2 is -6. And so then if I take that -6, that's what? -12/3 plus 8/3? No.
I think I went ahead and did 6s.
Yeah, and I'm going to back up and do 6s because I just goofed that up. So forget it. I'm trying to be fancy. Never mind. -24/6 plus 16/6 minus 12/6. How about -26 when I get that done? 16 minus 12 is 4, -24, and 4 is -26. Yeah. 27/6. This is area, so I am going to officially say units squared. Oh, hey, that doesn't match my answer key.
What'd you get?
9/2.
Yeah, so
It reduces. That moment when I glance down, I think, oh no, what'd I do? But 27/6 reduces to 9/2.
It's right in the AP book, so.
Hey, and you know what? On AP exam, guess what? 27/6 is perfectly fine. So I wouldn't miss anything.
Correct. That's so unlike